All right, hello again. In this video, I'm just going to get you started on the Logic 2 worksheet, problems 5 and 6. Right now, we're starting to deal with quantified statements. All right, so let's look at problem 5, the first true-false. You'll notice that this also is the first one in 6. All right, so the domain of discourse in this case is the natural numbers, the positive counting numbers and 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, on and on and on and on and on. All right, so in problem 5 here, in this first one, let's look at this first one here. All right, this statement says that there exists some x, there exists some natural number, there exists one of these infinitely many numbers here. There exists one of these infinitely many numbers here that you can put in for x and get a true statement. That true statement being that you put one of these positive numbers or 0 in here for this x right here, and you get that x plus 10 is equal to negative 12. And you can see that that's just not the case, right? There's no way you can put another positive in there and get a negative out. All right, so the answer is false. Another way to kind of see this, right, is you could solve for x. So x would have to be negative 22. Well, that just can't be the case, right? Because our domain of discourse is only the positive counting numbers and 0, the natural numbers. And negative 22 is not one of those numbers, so it's got to be false. All right, let's move on to the same statement, but in the world of the integers. Now, in the integers, we have the negatives as well, right? So in this case, the answer is true, right? This is because negative 22, as we solved for above, right? Negative 22 here. Negative 22 is an integer. So there does exist an x in the integers, in the domain of discourse, for which this is true. All right, now some of these that are the same for both 5 and 6 are going to be true for both of them. Some are going to be false. Some are going to be true in one, not in the other. All right, good luck.